This lesson is over line graphs, stem and leaf plots, and circle graphs. So we'll start with line graphs. Line graphs show trends over time or relationships that can be useful in predicting future events. For example, the graph to the right shows the relationship between temperature readings, degrees Celsius, and degrees Fahrenheit. So it says if 32 degrees is freezing, what is considered freezing in Celsius? So first of all, here's our Fahrenheit, and that's the first number that we have. So if you notice, we see that 32 is right here on this axis. So what that means is at 32, what's considered freezing? That would be 0 degrees Celsius. Now we're going to predict the temperature reading for 35 degrees Celsius in Fahrenheit. So this line, if you used a straight edge to continue it all the way to the edge of the graph, then 35 is right here, and if you trace that line up, it would hit the graph right here, which means the x value at this point is 35. We would be looking for what that y value is, which happens to be about 95 degrees, and that's Fahrenheit. Line graphs are not always straight, like the example above or on the last page. Sometimes line graphs look like these two examples. So it's just plotting using sections of a line. So this one says, between what two times did the store experience the most drastic change in store traffic? So from 10 to 11, it was about 10 people because it went from 20 to 30. From 11 to 12, it went from 30 people to about 55. So that's going to be 25. From 12 to 1, it went from about 55 to 70. So that's going to be 15. And then this one's obviously going to be less than that. So I'm going to look at this one. This one goes from 80 to a little over 50. So that's about 30 people. To me, this looks like it's going to be the most drastic change between 2 and 3 p.m. Now notice I didn't care whether it was a positive increase or a negative increase. I just wanted to see which one was the most drastic of a change. The next example has two line graphs shown. This one is Broward County. This one's Miami-Dade. So our population and the year. So how much larger was the population in Miami-Dade than Broward County in 1980? So at 1980, we look like we're right about at 1 million. And, excuse me, Miami-Dade was just a little over 1.5 million. So I'm going to say it's about 500,000 people. The next thing we'll talk about is stem and leaf plots. In stem and leaf plot, the data is organized from least to greatest. Excuse me. The digits of the least place value form the leaves, and the next place value form the stems. So, for example, we have this chart over here. We're going to organize this information from least to greatest. So my smallest number is 5. Now, because most of these have a tens place, this is the same thing as 0, 5. So this is going to be my stem, and this is going to be my leaf. So the 0 is my stem, and these are all my leaves that have that stem. So 5, 0, 6, 7, and then that's all my single digits. Now I'm moving on to my double digits. My next lowest number is 10. So with my 10, this will be my stem, and that'll be my leaf. So 10, this represents 11, 11, 12, 12, 12, 13, so on and so on. And then when I get to my 20s, the 2 is my stem, and those are my leaves. So this is what we call a key. You're always going to want to create that. This tells you the stem, and this tells you the leaf, and it's telling you that that together represents 12. So it's telling you those place values. Remember to always write a leaf, even if it repeats. The 1's digit of this data forms your leaves, and the 10's digits forms your stems. So we're going to create our own here. Notice we have a 0. So that's going to go first. And I'm going to say my stem is that, and my leaf is 0. So this represents 0. I'm looking for other single digits. I have a 5. Now I'm moving on to my other ones. Now, on this, I don't have any 10s. I'm still going to write my stem, but there are no leaves because there's nothing with a 1 in the 10s place. I do have some 2s. See, this 24 is the only one I have. Oops, sorry, I have a 23. So I'm going to go back and I'm going to erase that 4. And then I'm going to write my 23 and my 24, because remember, it has to be least to greatest. So then I'll start with my 3s. I've got a 30. I have another 30. I have a 35 and a 39. Please try to be neat when you're making these and make sure you line all your leaves up. Now we have a 42, a 45, a 45, and a 45. A 47 and a 49, a 51, a 55 and a 56, and a 58. I don't have any 6s, but I do have 2 75s. Okay, so what is the range of the data? Well, your tallest or your largest value is 75 and your lowest value is 0. So the range is 75. The mode is 45, where the leaves repeat 3 times. The median of the data is a little bit trickier. You're going to want to start at the end and at this end and start crossing off. 0 and 75, 5 and 75, 23 is next, 58, 24, 56, 30, 55, 30, 51, 35, 49, 39, 47, 42, 45, and now I have 2 in the middle. Please remember that this is 45 plus 45, which equals 90, and I'm going to divide that by 2 to find my median of 45. The average amount of pasta that people in different countries consume each year is shown in the stem and leaf plot. Based on the data, what inferences can be made about pasta consumption? So we're looking at this, and the answer for this could very much vary, but the main thing that I would look at is the mode. I can determine that most people, since there are so many countries listed in this area, that most people eat between 10 and 19 pounds, that's most countries, not most people, each year. Oops, sorry, I pressed a button. It says, what is the most common amount of pasta consumed? See all these 5s? That's 15. So 1, 2, 3, 4, 5. 15 occurs 5 times. Nothing else occurs that many times. The last one we're going to look at today is circle graphs. Circle graphs show how a whole is divided into parts. Each sector is measured using a central angle. So what that means is that we're going to have a circle, and circles always have a center. So if you cut that circle into pieces, however you decide to cut it, each of these pieces is what we call a sector. And it's measured using what we call a central angle. And the central angle comes from the center, and it's an angle that cuts off a sector. So again, this is the central angle because it comes from the center. So the circle and its interior are called a circular region. So in other words, that means the whole pizza. The sector is a part of that circular region. So in other words, a piece of pizza. All the percentages in a circle should add up to 100 because we're talking about a whole thing, and all percents come out of 100. So 100 represents the whole. And all the degrees in a circle add up to 360. So this angle will measure a certain amount of degrees. This angle will measure a different amount of degrees, possibly, or it could be the same. And this angle will measure a third, or maybe the same as one of the other, degrees. And all of these added together will have to equal 360. The reason that we talk about this is because we're always going to be talking about a part as compared to the whole. So a percent, say it's 30% compared to the whole 100%, would be a part, some other part, equal to some other part of the circle compared to the total part of the circle. So for instance, you could have the percent compared to 100 and some degree compared to 360, as long as the total is always on the bottom. So we're going to be setting up percent proportions, and we're going to be using cross products, in other words, cross multiply and divide, to solve this information. You should always label your sector with a name, the percent amount, and the degrees if possible. You at least need 2 labels. So let's look at an example. This one says, Ms. Kiddo surveyed 50 people, asking them what their favorite type of movie snack is. So this is going to be your total. So when we look at this, 20 people asked for popcorn. So 20 people out of 50 people is what out of 100? Well, using your factors, this is times 2, so this should be times 2. So that's 40%. 15 out of 50 liked candy bar. So times 2 times 2, that's going to be 30%. 10 out of 50 is what out of 100? So times 2 times 2, that's going to be 20%, which means this last one should be 10%. 5 out of 50 is what out of 100? So if you add all these up, it should total 50. If you add all these up, they should total 100%. That should make sense because we're talking about parts out of whole. Next thing we're going to do is find the degrees. Now, you can either use the percentage or you can use the people. It doesn't matter because it's all about part to whole. So if you've got 20 people out of 50, we want to know what degree that is out of 360. Or you could do that this was 40% out of 100, and that is what out of 360. Okay. Now, it might be easier to just cross multiply and divide on these. So 40 times 360 is 14,400. If you divide that by 100, you get 144 degrees. Okay. So therefore, I already know what 10 is going to be because that's half of 20. So half of 144 is 72. So you should always be double checking or trying to find shortcuts to do your work so that you don't have to spend a whole bunch of time multiplying. But the proportions that we could use for this type of problem are these. For 15, we could do, okay, 10 divided by 2, so 72 divided by 2 is 36. And again, I could have used 5 over 50 is x over 360. Or 10 over 100 is x over 360. Okay, and I got my 36 degrees. Or you could have just said, okay, well, I'm going to divide by 2, so I'm going to divide by 2. So if I wanted to find 15%, 5 and 10, or sorry, not 15%, it's actually going to be 30%, but 5 and 10 people should be 36 degrees and 72 degrees added together. Should give me 108. You can always double check that with your proportion. This is going to be 15 out of 50 is what out of 360, or 30 out of 100 is what out of 360. Either of those proportions will work. If you add up all these degrees, 144, 108, 72, and 36, they total 360. That should make sense because this is the total degrees in a circle. And of course, these add up to 50. So once we know those degrees, we're going to label each of these sectors with 3 different labels. Number of people, percent amount, and degrees. So the smallest section was sour worms at 10%, and that was 36 degrees. The next largest portion was trail mix at 20% and 72 degrees. We had candy bars at 30% and 108 degrees. And then our last one was popcorn at 40% and 144 degrees. Okay, so eventually we will learn how to create these sectors using the degrees we found, but for now they'll pretty much be proportioned for you, or you'll be looking at something that's already completed. So that's all for today. Please complete the next few pages in your booklet.